So if you remember from yesterday, we started looking at graphs of these linear inequalities. So we started that yesterday, and we're going to finish up today in part 2 of these notes. The objective for today is to write inequalities in 2 variables and make sense of the solutions by reasoning and graphing. Yesterday, we were looking at a lot of graphs that didn't have any sort of like context or real world situation. And today is going to have a lot more of those. So hopefully it'll help you kind of solidify and cement all the stuff you learned in yesterday's lesson. Our warm-up for today says landscaping options, and it tells us a homeowner is making plans to landscape her yard. She plans to hire professionals to install grass sod in some parts of the yard and flower beds in other parts. Grass sod installation costs $2 per square foot, and flower bed installation costs $12 per square foot. Her budget for the project is $3,000. The first part of the question is asking us to write an equation that represents the square feet of grass sod, which is going to be X, and the square feet of flower beds, which is Y, that she could afford to use if she used her entire budget. So we're writing an equation that represents the constraints of this problem here. I'm going to give you guys take like 30 seconds, see if you can come up with an equation to represent this, and then I'll have a share out. Hey, Moji Raya.
Good afternoon.
And once you have an equation, feel free to shout it out. Let's have one person share, and then we can have another person see if they agree with it or not.
I have one already.
You got it? Can you tell us?
I have G2 plus 12F less than or equal to 3,000.
12F less than or equal to 3,000. Did I get that right?
Yeah.
Okay. Moji Raya or
Or 2G. We can do 2G or FM.
Okay. Yeah, we usually see the numbers in front. So let's change
that. F12.
Moji Raya and Sheila, do you agree? Disagree? Is there anything you would change?
Let me read the question.
Please, I need a pencil.
An equation, not an inequality.
Okay, so I hear Sheila saying it's pointing out it says an equation because we're spending the entire budget. So if we want that to be an equation, let's change it to equals. So 2G plus 12F equals 3,000. Are we happy with it now? Anything we want to change?
Good eraser.
Thank you. Oh, sorry.
What I want to point out is in this problem here, they're giving us the variables to use. So they're telling us let's use X for the sod and Y for the flower beds. So let's change. I see where the G and the F are coming from, but let's change those. Let's change G. Should G be X or Y?
X.
X, and then the F, the flower beds, will be our Y there. Nice. So we get this here as our equation. I'll make it a little bigger on my screen too. We're saying $2 times the square feet of sod plus $12 times the square feet of flower beds equals that total budget, the $3,000. The second part of this, we're going to come down here, taking that equation you all just wrote, and we're going to sketch a graph of this equation down here. As a reminder of like the different strategies we learned for graphing equations, if the equation is in slope-intercept form, so that's that y equals mx plus b. If it's in slope-intercept form, we could use the slope in the y-intercept to help us graph. This equation here is not in slope-intercept form, So a different strategy that might be easier is to use the X and the Y intercepts. Figure out where that line is crossing our x-axis and where that line is crossing our y-axis. To give you an example, if I wanted to find where that point is on our x-axis, that's going to be how many square feet of sod she can afford if she gets 0 square feet of flower beds. Looking at the information here, looking at your equation, if she gets 0 square feet of flower beds, how many square feet of grass sod could she afford? And there might be some calculations we have to do there.
That should be 1,005.
I'm sorry, can you say it again?
I said maybe 1,005 feet.
1,005? 1,500 feet? How'd you get that?
Okay, because our equation is saying $2
Mhm.
per square feet, and the total money spent is 3,000. So I think 2x.
So we're saying 0 for our y then. 0 for the square feet of flower beds. That just gives us this. And then when we divide that by 2, we get that 1,500 Sheila saying. So that's giving me 1 point on the line. That's giving me the point. If she buys 0 square feet of flower beds, that's 1,500 square feet of sod. See if you can figure out where the other point is going to be on our y-axis. I'll give you guys, take about 30 seconds to do that, and I'll move this up just a little bit more so you can see all the information. We're trying to figure out where our line would cross on the y-axis.
$250. On the y-axis, that's gonna be on the 250.
250? How'd you get 250?
Well, I did the same thing I did to solving for x.
Mhm.
So I did 12y. No, I did. Okay, let me go back to the equation, the normal form of the equation. That's 2 brackets 0
Mhm.
plus 12y.
So then we just get that 12y equals 3,000. We're saying if we get 0 square feet of sod, we're trying to figure out how many flower beds that would be. And then when we solve this equation, like Sheila said, it's similar to what we did for that first part. We're just changing which variable equals 0. And we get y equals 250. Finding those 2 points helps me out because now I've got 2 points on my line. So all I have to do now is connect those 2 points to get the graph of the line. So I could come in and connect them. Let's see if I can do this. Whoop. Almost. There we go. It should be a straight line. Maybe let me fix it. But we get our lines going to go through those 2 points there. Let's try this again. There we go. Okay. Some follow-up questions from these first 2 problems we're working on. What does it mean if the point falls on this line we just graphed? For example, this point right here falls on that pink line we just graphed. What does that mean in this situation? What does this point here represent?
That means that if we do the calculation, that means she was able to buy 150 square feet of flour bed
Hmm.
and 600 square feet of grass.
So I hear you saying she was able to buy 150 square feet of flower beds and 600 square feet of grass sod. There's one other piece to that. She was able to buy those quantities
with our budget.
with her budget, with the $3,000. She could buy exactly that many square feet of flower beds and sod and spend exactly $3,000. So this line here is showing all those different combinations of sod and flowers that equal that budget. This is something we had looked at back on in our lessons where we were talking about equations and graphs of equations. We're going to build on that today as we look into inequalities, but the basis of it is the same. We're building on what you already know about graphs of equations. We're going to continue on. We're still talking about landscaping in the second one. And in the second part, they tell us the homeowner is worried about the work needed to maintain a grass lawn and flower beds. So she's now looking at some low maintenance materials. She is considering artificial turf, so like fake grass, which costs $15 per square foot. So we've got the turf, which costs $15 per square foot to install. And then the gravel, which costs $3 per square foot to install. And just like before, she's going to use a combination of the two materials in different parts of the yard. Her budget is still $3,000. Here is a graph representing some constraints in this situation. So similar to before, we've got a line. The x-axis is showing the gravel in square feet, and our y-axis is showing the square feet of artificial turf. Looking at this graph here, number one shows that that graph in the line in our graph is going through the point 500, 100. Let's start off. What does this point here represent? What does that 500 and 100 represent? Sheila told us before, so Moji, Raya, or Deborah, can one of you tell me what the 500, 100 represents? Deborah, Moji, Raya.
500 gravel.
represents. Go ahead. No, go ahead.
500 gravel 500 gravel square foot, square foot of gravel, and then 100 artificial 100 square foot of artificial turf.
Yeah, perfect. I like it. And you're doing a good job of reminding us that first number is that X, so it represents the gravel, and then that second number is your Y, so it's representing the turf there. So we know what 500 and 100 means. Looking at this line here, let's write an equation for this line, just like how earlier we had an equation. You could use the graph, you could use the information here in this paragraph. What would that equation look like?
We might have to
500x plus 100y equals 3,000.
Tell me what X and Y represent.
X and Y represent the gravel and the artificial turf.
Nice, the artificial turf there. Did I spell that wrong? Artificial. Okay. So we're getting that X. It's coming from that X-axis, the gravel. The Y is coming from the artificial turf. I could add in like the square feet of gravel and the square feet of artificial turf. Let's look at our equation. This equation is saying we're multiplying the square feet of gravel by 500 and multiplying the square feet of artificial turf by 100 to equal that budget of $3,000. Look at that equation again. If I'm multiplying the square feet of gravel by 500, that's expensive.
No. Sorry. Sorry, I just read it now. Which
15,
cost
15
15?
times 15
Yeah.
times 15x
Yeah.
times 3y
Mm-hmm.
equals 3,000.
Yeah. Sorry.
Tell me how you're getting that. Where are those numbers coming from?
The x is the total. How do I call it?
The X is the square
The,
foot of
the
gravel.
total square foot of the gravel,
Mm-hmm.
and the y is the total number of the total of the artificial
Turf. Mm-hmm. So the cost of each of those, be
the
real
cost.
careful. Come back up to this paragraph. So you correctly said X is the square feet of gravel. Right now we're multiplying the square feet of gravel by $15. Read through this paragraph again here.
She's considering artificial turf, which costs 15 square feet to install, and gravel, which costs $3 square foot. Okay.
X is the
So,
gravel.
so
Yeah.
no, it's going to be 3x plus 15y equals
Yeah.
8,000.
Yeah, we had our numbers backwards.
Mm-hmm.
We've
Yeah.
got X, the square foot of gravel. That's what I underlined in pink. That's the $3 for each square foot. And then the turf is 15. So we've got our equation. Now we had been talking about this point earlier, this 500, 100. We noticed it was on the line. You guys told me what those numbers mean. What does it mean that 500, 100, that point there is on this line?
That's 3 times 500.
You're doing some math. 3 times 500.
Plus 15 times 100. Let's see that's what that gives us. 1,005. Then yeah, that's 3,000. Correct.
Yeah. So I like how you did that math to figure that out. So that point being on the line means it's equaling that budget of $3,000 there. In order to be a solution to this equation, it's a point like 500, 100. It's a point that's on the line because any point on these lines is a solution and is a combination she could buy for the $3,000. Now, looking at this graph here, we've got a couple more points that we're going to look at. We figured out this point here, 500, 100. It's on the line. It equals $3,000. Let's look at the next point, 600, 200. Notice up here on the graph, 600, 200 is above the line. It's like to the right and above that line right there. Thinking about that point, 600, 200, would that combination of turf and gravel meet the homeowner's constraints? What do you think?
Can you say the question again?
I'm looking at A right here, which says, does that combination of turf and gravel meet the homeowner's constraints?
Yes, it does.
Wow.
I hear a yes, it does.
Mm-hmm.
I don't think so. No.
No,
That's above the budget.
it's above the budget.
Which one? Oh, the blue one. Oh, sorry.
The budget
It's
is
above.
3,000, and when we have 600 and 200, that is
Oh,
above the
that's
budget.
above. That's true. I was looking at a different
So
one.
if we multiply 600 times 3 and we multiply, so it's above the budget.
Yeah.
You didn't even finish doing that math. You're just like, no, it's going to be above.
No, it's above the budget. So
Yeah. We can finish that math. 600 times 3 is 1,800. 15 times 200 is 3,000,
so
which I agree. That's going to be above the budget.
3,000, yes.
You do all that math, it ends up being $4,800. So one way you could explain why it doesn't meet the constraints is what we were doing here. You can do that math and show, nope, it's not meeting that constraint. It's not equal to that budget of $3,000. It's above the budget, like you said. How could we use the graph to argue that 600, 200 does not meet the budget?
We could tell that from the graph, we can see that it's above the constraint that she has. So
We dotted it.
if we are to flip it, then probably, but so we can just dot it like Mujiraya said.
Yeah.
Or shade it. We can also shade.
So you guys are getting to the punchline of this question, which I love.
The line will be like what do we call it? Is it we perforate it or we dotted it? The line.
Dash. So
Dash.
you bring in some of the stuff we talked about yesterday, which I love. Remember, we're looking at this point here. This point is not on the line. So we're not changing our line. But you were talking about shading. You figured out 600, 200 is not, it doesn't meet the constraints. It's not a part of the solution. Should this point be shaded? Yes or no? Should it be in a shaded area?
Yeah.
We're shading. We were using shading yesterday to show where the solutions were.
Yes, we can
sorry. No, we can't.
We can't shade it because it's not the solution.
It's not part of the solution.
Yep,
So
I hear you both saying.
we can only shade when it is the solution. But once it is not the solution, according to what you said, we can shade there.
Yeah. So I'm just going to put over here. So that point right there shouldn't be in a shaded area because you just did the math to figure out it doesn't meet the budget. Now you were talking about the line and using like a dashed line. That point 500, 100 is on the line. Did 500, 100 meet the budget?
Yes.
Yes. So then that means that point on the line is a part of the budget. It is a part of a solution. If I used a dash line, that's what you were saying earlier, we would use if it wasn't a solution. But because the points on the line, like 500, 100, are solutions, we're using that solid line here. Now there's one last point for us to look at, that 200, 100. Let's look at that point there. The point 200, 100 is located to the left and below the line. Would that combination meet the homeowner's constraints?
Yes.
Tell us what you did to figure that out.
That's 600 plus 1,005 gives us 2,001. So, and the constraint is 3,000. So
that
is either less than or equal to.
Less than 3.
Mm-hmm. So I heard you did all this math. I'm catching up. So you did that math. You got $2,100, and I heard which is less than our $3,000.
Yeah.
So it's within the budget.
Yeah.
Let's choose another point in that same area. So we were doing this point 200, 100. Pick one more point for me in this area below the line.
675.
75, sure. Let's see, 75 is right here between 50 and 100. Okay. So we're going to go with 675. Let's check that. What are you expecting to see? Are you expecting it to be a solution, to not be a solution?
To be a solution.
Going to be a solution.
Let's do some math to confirm. That would be 600 times the 3 plus 75 times the 15.
Mm-hmm.
I know 6 times 3 is 18. So 600 times
1,008. 1,008 plus
and then 75 times 15.
75 times 15. That's 1125.
So then when we add those, 2,000.
2925.
Yep. So really close to the budget, but it's still within budget. And notice the location of that point Deborah picked for us. She picked a point that was really close to that line, but still under the line. It matches up with the math. Our math is showing that it comes out really close to the budget, but it's still under the budget. So the relation of those points to the line also is telling you something too about how they're meeting the constraint. But like you guys predicted, you said you were predicting it to be within budget, and once we did the math, we confirmed it was. So this whole time we've been working with the equation that represents spending exactly $3,000. But I heard a moment ago you were talking about, well, to be within budget, it needs to be, it's not just equal to 3,000. Do you remember what you said? I can't remember who I heard say it.
Is it when it's above the constraint?
So let's read number 4. It says, write an inequality that represents the constraints in the situation. Explain what the solutions mean. So we've been saying that it's $3 for each square foot of gravel, and it's $15 for each square foot of turf. We've got a budget of $3,000. What inequality sign would we want right here?
Less than or equal to.
And Sheila, I hear you very softly in the background. Were you saying the same thing?
Yeah, less than.
Yes.
Less than or equal
Or
to.
equals to 3,000.
Why less than or equal to?
The constraint is 3,000, so it shouldn't be above the constraint. It could be less than the constraint, but not above the constraint.
Love it. So I hear you saying that $3,000 is the constraint. That's our budget. We have $3,000. It can be less than $3,000, but not above.
More than 3,000.
Yeah, that was going to be the second part. Or it can be exactly 3,000. You can spend all of that money. So that's where that or equals to is coming from. It can be less than $3,000, or you can spend exactly $3,000. Now, earlier, this graph we've been looking at, this is a graph of an equation. That's why there's just a line there. If I wanted to show the graph of that inequality, you were also talking about this earlier, what change would I need to make to this graph to show the graph of that inequality?
Just shade the below.
Shade below.
Everything, yeah.
Why am I shading below?
Because that is the solution.
Because any point around that
shaded area
is the solution.
Yeah. And what does it mean to be a solution in this situation? I agree with you. It's a solution.
It meets the constraint.
Yeah. It meets the constraint. Who can add on to that?
It meets the budget constraint of 3,000.
Yeah. It's a combination of.
It means the price of the gravel and the turf, all the money spending is not above the constraint, is within the budget or equals to the budget. So
yeah,
it's not above the budget. It's either equals to the budget or within the budget.
You got it. You got it. So that's what we had been working on yesterday, is this idea of to show that all of these points, any point in this area here is a solution point, we're shading. And to be a solution means what you guys, I hear you saying, it's meeting the constraint. It's within that budget of $3,000. We could look at this graph here and see all the different possibilities this homeowner has for that money. She could look at this and say, okay, well, if I want a lot of gravel, I know I can pick, like 700, 800, even 900 square feet of gravel and see from this graph how much turf then she could afford. So it's showing all those different combinations at once with this handy graph here. Nice. Nope, that was the last question there. Okay. You all are doing awesome. How are you feeling about this question here? Are you feeling better than we did yesterday? Do you have questions for me before we move on?
Yeah, good.
Good?
Thank you.
Yeah.
Okay. Let's see. We'll come down then to, which one do I want to do? Yeah, let's look at this one. So we've got the third activity we're going to look at is called the Saturday market, and it says a vendor at the Saturday market makes $9 profit on each necklace she sells and a $5 profit on each bracelet. The first question is asking us to find a combination of necklaces and bracelets that she could sell to make exactly $100 profit, and then a combination she could sell to make more than $100 profit. Similar to above, there's going to be multiple correct answers for each of these. I'm going to give you all, take about a minute to see if you can find a combination that meets each of these descriptions here. And then afterwards, we'll share out.
You can have 020.
020.
Oh, sorry.
45.
Sorry. Yeah, 020. Correct.
020.
Or
So
45.
just to confirm, you're having X represent
0.
Yeah.
X represent the necklace,
Yeah.
and the Y represent the bracelet.
And I'm just going to clarify the number of necklaces, and then Y is the number
of bracelets.
Okay. So 0 necklaces and 20 bracelets would work out to be exactly 100. Yep. Because you're just selling bracelets, so that's 20 times the 5 to get the 100. Did anyone else find another combination?
Mujiraya said 45.
Did you? Okay. 4, 5. So let's see that. So 4.
45, will that work?
Oh.
4 times 9, no.
Oh, it can work.
It can't. It says exact. You can also have 100 divided by 9. That's 11.
The one I came up with had 10 necklaces. If we sell 10 necklaces, how many bracelets?
We have 10, 10 4. We can have 10 4.
That's 10 2.
That should be 10.
We can have 10 4.
Sheila's so quiet.
I said
We can have 10
2.
4.
It's 10 2.
I'm hearing some 10 2s.
It's 10 2.
10 necklaces would be $90 there. So we would need 2 bracelets to give you $10 and make exactly 100.
That's my error.
So what about more than $100? Mojiro, you might have one for us.
So that can be 4 5.
4 5?
Yeah, like the one Mujiraya said before.
Let's just check. 4 necklaces is how much money?
That's 4 times 9.
There is 9, not 8.
That's 136. Sorry, 4 times 9 is $36, and then 5 times 5 is 25. Oh, no. That's not gonna work. No, it's less than $100. So we can change that to probably.
And take 9 4.
9 4. Yeah. Let's try that. So 9 times
9 is 18. 81. Plus 4 times 5 is 20.
So that would get us over 100.
That is above 100. It's more than 100.
Can also have 10 4 or 10 5.
Yeah, we've got these combinations here are exactly 100. So if you add to these, that would be more money, right? So 10 4, that's just extra bracelets. I could take that 020 maybe and do like 10 20. Because I know this is giving me exactly 100. So any more than this would be more. Like I said, there's millions of correct answers. We could get really ambitious and say, oh, if she sold 1,000 necklaces and 1,000 bracelets, That's for sure going to be more than $100. So there's tons and tons and tons of correct answers here. The purpose of this was to get us started, so we've got a couple points. We're going to come down to the second part, which says write an equation whose solution is the combination of necklaces and bracelets she could sell and make exactly $100. So based on this information here, we're going to write an equation to show how many necklaces and bracelets she would need to sell to make exactly $100. Take a moment, see if you can come up with an equation. Don't share out yet. I want to give everyone a chance to an equation, and then we'll see what we got.
Okay, I'm ready.
9x plus 5y equals
He said don't shake it.
It's all good. 9x plus 5y equals
Okay.
100. She likes so quiet, it's hard to hear him sometimes, so I'm glad I got that. So we got that. Deborah, you said you were ready too. Is that your same equation?
I also have xy equals 100. Is that correct?
xy.
Yeah, that's the first one. 9x plus 5y, but then I also think maybe xy equals 100. Can we write it that way?
x
Let's
plus
talk through this one.
20y.
Yeah, that's what I want to know. That's why I put it that way.
X plus 20y should be 100. We're using the other.
We can say xy equals
So
100.
can we say xy or can we say x plus y?
No, we can say xy is equals 100. If we say xy equals 100, that means we don't know the total number of necklace sold. So
That's
that
what
means we are just
we-
multiplying the 9 times 5 equals 100. That is what xy equals 100 mean, I think.
Use
So,
what we've
but
written right up here. If
so
we write xy, it does mean multiplication, but it means you're multiplying how many
9
necklaces?
times 100.
Yeah, that's
Not
what I
the
9
want.
times
top.
5.
I think that equation is just saying one necklace.
No, it's multiplying. I just wrote it as a second one to ask us the question.
I love
It's
your
wrong, but I know it. Yeah, but I just said it out.
So if we write xy, that's telling us we're multiplying how many necklaces she sells by how many bracelets she sells to get 100. And so I heard that. I also heard x plus y. That's telling us the total number of necklaces and bracelets she sold is 100. Not $100, but 100 items. So this
We
this
can't.
one. Whoop.
Yeah, I said we can't even say x plus y equals 100.
I agree.
So
That means
we
something
can,
different.
yeah.
You guys got the equation though. We got 9x plus 5y equals 100.
think
That's the equation we'll use.
I think we can use this other equation, x plus 20y equals 100.
Equals 100. So this equation here is saying x. So there's like a 1 there. So that's $1 for each necklace, $20 for each bracelet equals 100. Remember, our equation should be describing, I should be able to put any pair of numbers that we said is a solution into this equation and get something that's true. So if you wanted to test this equation, notice earlier we said 0, 20. I could test it by making sure if I replace x with 0 and 20 with y, I could make sure that that math works out to equal 100. Same thing with 10 and 2, which it does. So we've got our equation here. Let's look at that equation. That equation describes how many necklaces and bracelets she could sell to make exactly $100. We're going to write in an equality that represents the combination of necklaces and bracelets she could sell if she wants to make more than $100. What do you think that inequality is going to look like?
More than $100. So we can say 9x plus 4y.
5y or 4y?
5y. Oh, sorry, no.
5y.
Let's go back. Let's use 10x.
Deborah, go ahead.
Yeah, 9x.
Because Miss Samantha,
Mm-hmm.
yeah, is 9x plus 5y equals 100. Is it
No,
exactly
that's
100?
wrong.
That one is wrong. So that is
Which
why I
the
said
first
Deborah
equation
should
is
go ahead
wrong
because
because
that's above.
that's what I was just looking
So
at
you are
now.
right.
9x plus. So the first equation is wrong. It
It's
cannot be
wrong.
exact 100 if we go by
Wait,
the prices. So which one is our x again? So our x is $9.
Yeah. And the
Yeah,
y is
yeah, that's
$5.
9 times.
Yeah,
Yeah,
you're
that's
right.
true.
You're
It's
right.
correct.
It should
wait,
9
It's
times 9
correct
is 81.
because you just
wait.
substitute.
that should be
No,
20x
9 times
plus
0, you substitute. It
2y.
depends on the value.
Are we
That
saying
question.
our answer for number 2?
That should be
Yeah.
10x plus 2y equals 100.
If when we
So
were
the
trying to
second
find
one would be
pause real quick for me. When we were trying to find pairs of numbers that equaled exactly 100, why, for example, why was 10 to a solution?
Plus 10 times
What
9
math did you
is
do?
90. You added
we multiply the price of the necklace by the number of necklace sold. So
Yeah,
then we'll also add it to the price of bracelet by the number of bracelets sold. So
yeah.
that gives us 100.
And I
But now,
love
yeah,
the way you just described that because you described it as we're multiplying the price of the necklace by the number of necklaces. We're multiplying the price of the necklace, $9 times X. And we're multiplying the price of a bracelet, $5 times Y. That's where this equation's coming from. It's saying $9 times the number of necklaces plus the
so for the
$5 times the number of bracelets equals
so for the
100.
next one, we only change the sign to greater than 100. So we can have 9x
Yeah,
plus 5y greater than 100. So it's
equals
now
yeah.
depend on the value we substitute into the x and y.
Mhm.
uh,
So similarly to what you were doing here in part B, we were doing the same math, right? But we were just checking to see, does it give you something that's more than 100?
so that
Which
would be
is
just exact equal
what,
to 100, not more than 100.
so if we want to make exactly $100, we need it equal to 100. If we want to make more than $100, we need it greater than
Mhm.
100. There's two last parts
Sorry,
to
Miss
this.
Samantha, before we
Oh,
go ahead, the, this inequality, is it correct? 9x plus 5y greater than 100, or is it greater or equal to 100?
so let's talk through the difference
Because this
between
is
those.
just going to be exactly 100. It can be. Okay. Okay.
So
It says
the
write
question
an
is which one
inequality
of
with
these?
solution and combine should sell and make more than. It's more than, so it's greater than. It's not telling us that it has to be 100. It says more than.
Okay. Okay. Yeah. I think I get you.
What could they have said there? What language could we use where this would be the correct one?
We could have said
Yep. I think that's the
at
most
least,
common one. If
at
you
least.
say she wants to make at least $100, that would mean
Mm-hmm,
you want $100 or more. You want equal to
mm-hmm,
$100 or more.
mm-hmm.
Because it specifically says more than $100, that's why it's just the greater than sign. I like how we went back to that language right there to help us decide. So we've got, and let me delete this real quick before it confuses us. So we've got our inequality now. The last part of this is we've got this inequality. Let's put it on a graph. Once again, because our inequality isn't in slope-intercept form, we've got it right now. It looks like this right here. I'm going to suggest let's find the x and the y-intercept. Similar to what we did, and I'll scroll back up to remind you how we did it. similar to what we did at the very beginning of this lesson right here, where we found those 2 points to help us graph the line. So take a quick look real quick at this. Remember how we did it. And I'm going to go back down to the inequality we're graphing. Take a moment and see if you can find those x and y intercepts to help us graph this line. And if you want to divide it up between y'all, you can. If someone wants to volunteer to find one and someone volunteer to find the other. So for example, we can do this again. If I want to find my x-intercept, if it's a point on this x-axis here, that's going to be the number of necklaces she needs to sell if she sells 0 bracelets. All these points here on the x-axis have a y-coordinate of 0. So to find that x-intercept, I need to figure out what x equals when y equals 0.
If that means she didn't sell any bracelet and she didn't sell any necklace.
No, that would be the 0.00. If she needs to make $100, how many necklaces would she need to sell?
Okay, 20.
20. That you found the y-intercept, which is good. We want
so
that.
Y would be 20.
Y-intercept by making x equal to 0. If we make x equal to 0, that means y must be 20. So I can mark that point here on our graph. If our x is 0, y is 20. If she sells 0 necklaces, she sells 0 for x, she needs to sell 20 bracelets. What about the other one?
I actually got 11.1.
Are we talking about the y-intercept now or the x?
We're looking for the x.
Yep, 11.1. It's the same thing. Yeah, 11.1.
Oh, yeah.
So on the x-axis, it's crossing at 11.1. This line here is 10.
11.1. 11.1, that's 99.9.
Yep, so we've got that point, and then we can...
Please, how do you get 11.9? I don't understand that.
9 times 11.1 will give you 99.99.
So this
because
line
you're trying
right
to
here
look at
represents...
if it doesn't... Oh, sorry.
This line right here represents all the combinations of bracelets and necklaces that equals exactly... If we're trying to find the x-intercept, that is where y equals 0. Any point on your x-axis has a y-coordinate of 0. Take the and solve that equation for x. That's how you get 11.1. This is the same thing about graphing equations. If we're struggling to get the graph, I would love to see you for tutoring, and we could look more at graphing equations. I need to make sure we get to the inequality part of this lesson, though. We've got the line here. We're trying to graph the solutions to this inequality. Remember, we've been talking this whole time about how many necklaces and how many bracelets she could sell to make more than $100. If we've already figured out earlier, we figured out these here are examples of points of combinations of necklaces and bracelets she could sell to make more than $100. Thinking about that, we want to change our graph into an inequality. I need to shade the area that shows all the different combinations she could sell to make more than $100. Where should I be shading?
Just shade all the parts above the solid line.
Why am I shading above?
Because any point above that will give us a profit of over 100.
Yeah. For example, earlier you guys told me that 10-4. She sold 10 necklaces and 4 bracelets. That's more than $100. If I find 10-4 on my graph, that's 10-4. 10-4 is right there. Notice that is in that shaded area. We also said 10-20 as being a possibility. If I find that on the graph, 10-20 is up here. It's in the shaded area. So we're trying to make sure we shade everything that would give her more than $100. Now, the other part to graphing these is this line itself. I drew it with a solid line just to get the line on the graph. But we have to decide, should that line be solid or should it be dotted? And to figure that out, you're thinking about, are the points on the line solution points? Would any point on this line give her exactly $100? Or, so, I'm sorry,
Please, I'm lost.
they are not. Tell us why not.
I really don't understand how you get 11 points, whatever you get here. So
Okay.
not getting that is causing the confusion, and I really don't understand anymore.
Mojira, what it means is that if he buys 0Y, you know what Y means? If he sells 0 bracelets, how many necklace will he sell to make the $100 we are looking for? So we now divide the $100, by 9, because now he's not making any bracelet sales. So that gives us $99.9. So if you multiply 11.1 by the price of the necklace, it will give you the $100 we are looking for.
And Mojira, I'll have you, if you can stay on after we end the call, we can talk through it too. Looking at the points on this line here, these points are not solution points. If I sell a combination of things on this line, I am not making more than $100. For example, this point right here at 0.20, that's a point on the line. And we've already figured out if she sells 0 necklaces and 20 bracelets, she's making exactly $100, not more than $100. So in this situation here, points on those the points that lie on that line are not solution points. Just so to show that it's not a solution point, I'm using that dotted line there. We had also talked about yesterday, just look at this inequality sign here. If it doesn't have or equal to, it's a dotted line. If it does have or equal to, it'll be a solid line. That inequality sign there is telling you a lot about what this graph here is going to look like. This was the second part here of graphing linear inequalities. I think the parts we're struggling with in this lesson have nothing to do with inequalities. I think it just has to do with graphing equations of lines. So if that's the case, if you're feeling okay with all these calculations and with writing the inequalities, if it's just figuring out where that line goes and how you find those intercept points, I would really encourage you to come hang out with me and Denise during tutoring, and we can look at that. The fun, exciting news is tomorrow is our last lesson, the last new material we have to learn. So tomorrow we finish up what we're doing on inequalities, and then next week it's all about getting you all ready for that final. So this is where I leave you. If you've got any questions, feel free to stay on. Otherwise, we will see you all tomorrow. Bye, guys.
Bye. Thank you.